Everybody, welcome to another episode of Conversations with Tom. I'm here with Jamie Metzl. Jamie, I am super excited to talk to you about your book, Hacking Darwin. As I said, I was completely captivated by that book and what's possible with the human genome and all that good stuff. So, man, welcome to the show.
Thanks, Tom. Really happy to be here.
Cool. Well, give the listeners a just super quick thumbnail sketch of what Hacking Darwin is about. And because this is, as opposed to some of the science fiction stuff you've done, this is all science fact.
Right.
So what was it that made you want to write this book?
So first question, the book, I mean, if there's just a takeaway for people, our ancestors, they thought biology was just something that happens. You get born somehow. Now, suddenly, our one little group of monkeys who climb down from the trees, suddenly we have this ability to read, write, and hack the code of life. Like these superpowers that we've imagined are gods having to create life, to change life, to extend life. Suddenly, we have it. And it's going to fundamentally transform so many aspects of our lives, not just healthcare, but the way we make babies, the nature of the babies that we make, and ultimately our evolutionary trajectory as a species. And that really scares people because people say, like, well, wait a second, I'm a Homo sapien. I like being a Homo sapien. But when you kind of imagine the whole range, the temporal range of human evolution, we've only been this for about 300,000 years, which is kind of nothing. So this was never the end point of our evolution. But I think for a long, long time, people haven't imagined that we were going to be the drivers of our evolutionary process on a biological level. And that's kind of the essence of the moment. I mean, Hacking Darwin tells this whole story, from beginning to, there's no end, but into the future. But that's essentially what the core message of Hacking Darwin.
One thing that I found really interesting about the book is you talk about if we were to reach back into our past 1,000 years and bring either an embryo or an infant and then raise them in the modern world, they'd be indistinguishable from, who we are today. But if we were to reach 1,000 years into the future and bring that person back, they would essentially be superhuman compared to what we have now. And I want to stress again for people that are listening to this, what we're about to go into, at least this part, we may talk about science fiction as well, but this is science fact. This is shit that is happening right now. What is it, do you think, in terms of the person 1,000 years in the future, even just sort of extrapolating on technology that's real and being used today, what would be superhuman about them?
So lots of different things. And I think it's really hard for people to get their mind around this point, which I write about in the book. If you were to go back and kidnap some kid from 1,000 years ago and just put him into our lives, like, we would have no way of, they would just be exactly like us in pretty much every way. But that kid in 1,000 years into the future is going to live longer, healthier, more robust life. They probably weren't born by their parents fornicating. They were probably born because through a process in a lab. Almost certainly they were the result of their embryo being selected from among thousands. Which right now there is a process of selection in the sense that when a man's sperm, there's lots of sperm cells, more than 1 billion in some cases, goes into a woman, and they kind of swim around and they find the right egg. That there's a form of selection that's happening there. But what these kids 1,000 years from now are going to be born from is a selection that we are managing. We're going to be sequencing the egg and sperm. We're going to be sequencing probably many thousands of embryos. We're going to be selecting which one. And when you think about embryo selection, how did a wild chicken laying 1 egg a month become a domestic chicken laying 1 egg a day? Our ancestors did it not knowing anything about genetics. But if we have all of these generations between now and 1,000 years from now, where we are making informed, they may not be wise, but informed selections about which embryos get implanted in the mother, we can really push a lot of evolutionary change. And then we're going to go in and we're going to make edits to our genomes. And I don't think even 1,000 years from now, we're going to be making people from scratch, but we are going to be moving around a lot of the genetics in order to either prevent bad outcomes or increase the likelihood of things that we consider to be good.
All right. So I think it'll be interesting to go in and tease out some of the phrases that you've said and really talk about what that is. So we've got a chicken, it's laying 1 egg a month, and over time we're going to turn that into a chicken that's laying 1 egg a day. Basically what they're doing is they're looking for the one that lays 2 eggs a month, and then
Right.
they're trying to breed it with another one. And then when that one creates one that's like 2.5 eggs a month, you breed that one with
Right.
one that's doing a little bit more. And now all of a sudden, over generations, you get that it becomes very common for them to do one a day. Same with dogs, right? It starts with a wolf that's just a little more friendly than the next, and then flash forward, and I have a Pomeranian that wants to sit on my lap. So selective breeding, I think, is the term for that.
Yeah.
So you're just basically picking traits that you want, and then it has sort of a knock-on effect of other traits like the fluffier tail, the floppy ears. They weren't necessarily breeding for that; they were breeding for temperament. But you get this sort of knock-on effect.
Yeah.
Now, when we talk about,
and that's exactly, and I think that people kind of get that our dog that they used to be like a wolf, and now they've turned into dogs. But people have a hard time internalizing is that we used to be little single cell organisms. I mean, and I think that there's so much movement, so much possibility in all of biology, because almost 4 billion years ago there was just one single cell organism, and that grew into all of life. And so from this starting point of where we are now, there's an unlimited number of possible futures, even if we didn't have any of this biology, just because that's how biology works. Things morph. There's this constant, it's almost like a war of random mutation and natural selection where every new generation of every species is a little bit different from their parents. And sometimes it's better and sometimes it's worse. And over time, huge changes happen. And now we are amplifying and magnifying that process.
yeah, that is the whole notion of the blind watchmaker, right? That we've ended up the way that we've ended up through, I mean, if you believe in evolution, which I certainly do, that there wasn't like some desired outcome that was trying to be reached. It's your environment changes dramatically, sometimes completely without warning. What was working in a previous generation and the fittest of that generation now maybe the least likely to survive, and whatever adaptation has changed. And the fact that we went from oxygen being a poison to now being the very thing that we all need to survive, and just the way that things change like that. What becomes so interesting, though, is when you inject human consciousness into it, and it's now no longer a blind watchmaker. It is someone with a high degree of intention that is deciding through embryo selection where we're going to go. And that was the thing that really is so interesting in Hacking Darwin, is you keep telling these things like little stories, like, oh, imagine that you go into this, future, near future, by the way, and they're just asking you, hey, so instead of, implanting whatever it is now for IVF, like 8 or 9 or 15 embryos, it's 1,000. And we're able to screen them for high probability of certain outcomes, whether that's height, whether that's beauty, whether that's intelligence. And now it's like, do you want to know what this embryo has a chance of being? And if so, which of these do you want? And then you see how this really starts to become an issue. What are some of the, like when we talk about playing God, what are some of the key things that you think people will start selecting from when we're just beginning to dip our toe, that are sort of the non-controversial ones?
Yeah. So a lot of people ask about playing God. And what I always say is, whatever your theology, if you think that there's this all-powerful God who's making all kinds of decisions about how we live, and that God is deciding, I think this little kid should have some deadly genetic disorder, and this little kid should get run over, that's kind of a sadistic God. And so if you believe, as I do, that we are just one species among all these other species, and that we have, just like a lion or a zebra or whatever is trying to think, well, how do I maximize my chance of survival and well-being? That's why we have medicine and healthcare. That's why when a kid is born with a single gene mutation disorder, some terrible deadly disease, we don't say, oh, that's God's, I mean, some people do, but we don't say, oh, that's God's will. We say, to hell with that, let's fix it. And now that we have more and more of the power to make those kinds of changes. So the early manifestations tend to be simpler because we know there's a whole category of these what's called single gene mutation disorders or Mendelian disorders after Gregor Mendel. And that's where you have one gene, one problem with a single mutation. It's one letter that's out of place. But if you have that disruption or whatever it is, then you have one of these disorders like sickle cell disease or Tay-Sachs or whatever. And so it's a clearer case. We can just fix this one thing, and then a kid who was going to die when they were 5 all of a sudden has the opportunity to live to 90. But life isn't, in the old days, people used to think, oh, there's a gene for that, a tall gene, a short gene. But life, we're really complicated. We have our genetics, we have our broader systems biology. I'm sure your listeners have heard of the epigenome and the metabolome and the proteome and all these ohms that are part of who we are. And so we're going to need more and more knowledge and more sophistication to make smart decisions in this world of complexity. But we're going to get it. And the reason we're going to get it is because the complexity of our biology has remained relatively constant for millions of years, but the sophistication of our tools is increasing at an exponential rate. And just one example, in 2012, Jennifer Doudna at Berkeley and others, they developed this system for CRISPR genome editing. I think many people have heard of CRISPR now. 6 years later, 2018, the world's first CRISPR babies were born. So that it took 6 years to go from just something in a lab saying, hey, this may be an interesting way to edit the genome of a bacteria or the genome of a single cell organism or some kind of simple organism. 6 years later, the first human genome edited babies are born. So when you kind of take that.
For people that are flipping out right now, are we talking about the twins in China where they did the edit for HIV resistance?
Yeah.
That's pretty controversial though, right? It's not like people are like, hey,
no, I think it's
go
terrible.
for it. Go for it and prosper.
As a matter of fact, I think it's terrible. I think that He Jiankui, who's the doctor who did it, I mean, now we can talk about it later. Now it's like we've had 57 crises since then, so people are thinking about it less. But I think it was highly irresponsible. I mean, this technology was being used in plants and animals. And so the first step with humans needed to be done very, very carefully. And what he and others working with him were trying to do is just to race forward to try to claim some kind of glory. And it was very dangerous. Having said that, and I don't think it was, we don't know fully, but it looks like it wasn't even successful in conferring any kind of additional HIV resistance. But had he not done it, still, some years after, 5 years, definitely not more than 10, somebody else would have done it. I'm sure they would have done it, or hope they would have done it in a more responsible way, with a better target.
Yeah, I was going to ask, what is a responsible way? When we start talking about going in and I think it bears saying for anybody that's new to this, so basically they're using bacteria which have an ability to ward off viruses by recognizing a piece of the viral code. So the ATC, oh God, like whatever the letters of life are.
Yeah.
They recognize a repeating pattern in that, and they go, I've seen you before. And so they've developed the ability to go and cut that, and it basically unravels the virus, and the virus is done. So now once you have the ability to go in and cut a DNA sequence, you could go into a human DNA sequence, a plant DNA sequence, whatever, and humans can actually program the bacteria and say, go look for this sequence, which could be, in this case, the susceptibility to HIV. Maybe they were wrong, but that was anyway what they were looking for. Go and cut that out, replace it with something else, which you can also tell it to do, which is insane. And now you have the ability to actually genetically modify a human. Now you can
or
get into
anything.
like germline.
You can modify anything, and so what you've described is kind of the traditional CRISPR, but now there are new things, base editing, other ways where you go and
What's that?
Base editing. It's instead of cutting, you just change the letters, because when you cut, it's kind of an aggressive.
How in the hell do you do that?
These are all chemical reactions. So you have the same thing. You have the guide RNA telling you where to go, but instead of doing a cut, you basically replace one genetic letter with another. And the key point is this stuff, it's getting better, it's getting faster, it's getting more accurate every day. And that's why you talked in the beginning about science versus science fiction. Life is at the boundary between those two things, because real science that's happening now feels like science fiction, because we're all by definition wedded to the reality around us, and we have brains that have developed for practical thinking, in the sense that if you're kind of a crazy thinker in the African savannah, you probably are the guy who got eaten first, because the practical guy said like, oh, I think I heard a rustle in the weeds over there, I'm running. And the dreamer is kind of like looking up and imagining, flying spaceships. So we have these very practical brains by design, and we have these technologies that are advancing exponentially. And we have to kind of force ourselves to think like science fiction in order to really fathom the implications of the science fact.
Yeah, that's one thing you make a good call for in the book, which is, hey, I'm writing this because we need to be talking about this, which, by the way, humans won't. Humans will not wake up to this until there is a problem, until people start getting genetically modified. And then there's like the first time you have a debate as to whether or not Chinese athletes should be allowed in the Olympics, who's, got 3 times the muscle density of any other human being because they manipulated, oh God, what are the double muscled cows? Oh, I'm forgetting the name of it. But this is like myostatin. Yes. Like there's a real gene that says stop basically producing muscle, because muscle is actually dangerous when you think about a famine or something like that, because muscles take up so many calories. So the body actually has to stop developing muscle. So when you have that myostatin inhibition where it doesn't kick in until you get these, like you can see pictures of cows that just like look like they live in the fucking gym. It is hilarious. So when somebody starts making that edit and we see them roll up to the Olympics, now people are going to panic. That's like, in fact, back in the 70s when we had the first test tube baby, that was when people really started to go, oh, I guess this is really going to be an issue. I think it's super hard to wake people up.
It is.
But
well, not only that, the standard keeps changing, just in the sense that, most of us, most any athlete today could beat most any athlete from 100 years ago. We're all, almost all of us are immunized, which is this incredible superpower that our ancestors didn't have. And you talk about Louise Brown, the first quote unquote test tube baby, IVF. It's always shocking in the beginning, and then it's like, oh, that's the way we do things. And right now, I mean, we have this whole sport called weightlifting or bodybuilding. Now, one of those people could look like that if they were just living the life of our ancestors and eating plants and the occasional zebra or whatever. So I think that there are these shock moments of like, well, that's not normal. And then the idea of what's normal shifts. And so I think you're absolutely right. We are going to have genetically modified athletes. And we're going to want genetically modified athletes. And as a matter of fact, if we did a full genetic analysis of everybody who's won the Olympics in any kind of extreme focused sport like sprinting or marathon running or whatever, my guess is everybody is some kind of genetic outlier. We just haven't been able to look under the hood. And so I think it's going to be a question for us, what is natural, when the whole concept of natural is constantly moving and changing.
That's interesting. And then what humans say they want versus what they end up sort of voting for with their wallets.
Yeah.
So there was a really interesting movement in bodybuilding, probably in the 70s, where you had this whole, like, steroids were really coming on the scene. Bodybuilders were getting much bigger, way smaller than they are today, because steroids are crazy effective, and like we're selecting and pushing it farther than ever. But in the 70s, there was this real moment of like, hey, should we make this natural or should we go the drug route? And so there was a whole natural bodybuilding organization, and it just ended up getting its ass handed to it by the people that were on drugs. Now, obviously, they don't champion the fact that they're on drugs, and back then, certainly most of them would claim, no, what do you mean? I'm not doing drugs.
Right.
But it's just seeing them get that big, seeing them be that sort of peak shifted from what you see walking down the street is so interesting, and it draws people in that ends up being the one that gets the eyeballs and the most attention. So when you first said, like, we'll want enhanced athletes, I was like, what? Why would we want them? But putting it in that context of like, hey, if you've got somebody who can dunk a basketball on a 20-foot hoop, is that more interesting?
I think it's a great example. As a matter of fact, I started to write about that in Hacking Darwin, and I got these pictures of these guys who were like the world natural weightlifting or bodybuilding champion, and they were kind of all these puny guys, and you couldn't find one example of somebody who was in the kind of natural bodybuilding who looked anything like anybody who was in the world bodybuilding champion. And you're right. If we said, oh, we're going to handicap everything, and we only want these kind of quote unquote naturals, nobody wants that. No, people. What are people watching football here in the United States? I mean, they want bigger people. They want faster people. I mean, that's what's kind of interesting to us is, well, what are the limits of what it means to be a human being? And certainly there are rules in sports, and whatever those rules are, I mean, they're kind of random, but that's what makes a sport. You can say, well, it's cheating if you do something that's not in the rules. But there will be other people who will say, well, let's make an Olympics for people who are enhanced. And how many people are going to watch that enhanced Olympics? I mean, some of them will. And again, I'm not saying this is good or bad, because the answer is it's probably both. But I think there are a lot of people who say, well, I know what it means to be natural. I know what it means to be a human, and that's the line, and we can't cross that line. But how we define that is very, very different from how our ancestors defined it. I mean, I live in an apartment in New York. My ancestors were a bunch of nomads in the African safari. If I said, oh yeah, it's like a thing, it's a building, you have to take the elevator or go up the stairs, and there's air conditioning, and you don't have to hunt, you just kind of open the refrigerator and there's stuff there. Like, that would seem insane, and everything always seems insane, and yet we kind of keep moving. And that's why, for me, the ultimate question is ethics. The ultimate question is, what are we comfortable with, and collectively, and how do we make sure that for something that's this sensitive, we're moving forward in a thoughtful way together, rather than having a bunch of, that's why I'm a critic of Hu Jiankui in China, rather than having just a bunch of people making individual decisions, because the implications of those individual decisions are societal.
I don't think we ever got to the answer of what would be the right way to go about beginning to practice this on humans. What does that look like? Is it just, in fact, do you have a line? Is it disease removal purely? Is there something else? Like, how do we do it well?
Yeah, so there's no natural line, because a lot of, when I talk to people, what people feel like they want is, well, I'm for therapeutic applications to treat diseases, and I'm against enhancement. I think most people kind of feel that they want that. But when you push them of like, well, where does therapy end and enhancement begins? Like, if your child is going to be born and they're going to be 1 foot tall, and you have an intervention that can make them 6 feet tall, would you make that intervention? I think most people would say, well, geez, 1 foot tall, like, that's going to be really hard to live. Although somebody could put you in their purse and carry you around. And but then they say, well, I definitely want that. And then you say, all right, how about 2 feet? And they say, yeah, well, 2 feet is still too short. And at some point, you kind of get to 5 feet, and they say, well, 5 feet, that's within the realm of normal. Lots of people who are 5 feet tall have, and there's no natural line between those things. But for your question, I'm part of the World Health Organization International Advisory Committee on Human Genome Editing. And that's what we're trying to do, is at least to lay out what could be just some basic guidelines and parameters. And I think the two core principles, one needs to be cost-benefit analysis. I mean, to change the foundations of what it means to be a human, it's actually a really big deal. It's actually really serious. We don't know enough about fully how the human body works to feel that any change is costless. I mean, anything that we do, there's an upside perhaps, and there's a potential downside. And sometimes we don't know what those things are. So we need to be thoughtful about cost-benefit analysis, and we need to make sure that we're keeping society together, because when people start talking about changing their genetics, it's not just them. Especially you started to mention heritable or germline manipulations. If I have a germline manipulation and I have a child with somebody, then my children will also gain that change. And those kids will go out and live their life, and they may have kids with somebody else. So everybody else is a stakeholder in my decisions when we're talking about these kinds of systemic change. And I think they should be. And I think that's why we need to have these broader and inclusive conversations about the way to
Let me ask, why do you think that it matters so much? Is it purely the psychological component? Because let's say that if you introduced essentially you're introducing a mutation. It's very intentional, but you're introducing a mutation. That mutation is either going to work or it's not going to work. If it doesn't work, it's going to die out. And if it does work, then would not society, depending on what it is, obviously, would not society benefit from that? And look, I am asking a sort of devil's advocate rhetorical question. I am well aware of the implications of eugenics and all that terrifying shit. But what I'm trying to understand is, because I'm basically going to, whatever our big fear is, I'm going to say, okay, if we remove that, then where does the discussion open up? So is it the sort of moral implications of we shouldn't play God? Is it the societal implications like you're talking about, where it's like, look, we've got 7+ billion people, like it's shitty to make them obsolete versions basically, and you're introducing something so much better? Like that's sort of brutal in its own right. Is it the suffering of that one person that if you get it wrong, like fuck, like you could be messing them up in ways you don't even know till they're like 35 and then their face starts to melt? It's like you just don't know. Like where are the big, like when you guys sit down in your think tank room, what are you putting your finger on of like, this is where we can't go here for this reason? Yeah.
So personally for me, definitely playing God has nothing to do with it, because I write about this in the book. If you believe in that kind of God, then why isn't God playing God? Like, why isn't God preventing all these kinds of bad outcomes? For me, it's not inherently morally wrong. As a matter of fact, I could easily paint a scenario where it would be morally wrong not to intervene. I mean, if you had let's say you had one embryo, and if that embryo was implanted, it's the only one you have, your only chance to have a child. And if that embryo was implanted, that embryo would, when it became a child, would die very young of some terrible single gene mutation disorder, and it's not treatable. And I could easily make an argument that it would be immoral not to intervene, not to genetically engineer that pre-implanted embryo to make that one change so that kid could live a long life. And so I definitely think on a moral front, we have to be having these conversations. And I certainly was very honored. The Vatican published a piece of mine that's in my website on exactly these issues, and I raised some really challenging issues for them in how we should think about these moral issues. for me, the issue is societal, because we're not going to know whether any changes that we make are good or bad. Certainly, if you're saving a kid from death, that's good. But for these other kinds of changes, it may take a long time, and our biology is extremely complex. And so I just feel like if somebody is changing a system, and we're all part of that system. I mean, it's not because if it wasn't heritable, it was just somebody doing something to themselves, you can say, all right, well, you tried the kind of 3 eyes thing or whatever, and maybe it worked for you, maybe it didn't work for you. But when they're changing, we're all part of this connected thing of humanity. And I'm not saying don't change it. I'm just saying that changing it should at least partly be a collective decision. It's primarily an individual decision, but because individual changes, when they're heritable, will affect everybody else, we need to have some kind of process. And I think that this is life, and it's normal in our societies that issues that touch life are regulated, and we have debates on things like abortion versus choice. But at the end of the day, I think we recognize that life is really sensitive, and we need to have some kind of guardrails beyond just human self-experimentation. And we need to make sure that the science is good.
Okay, so now let's say I get it. You have been so clear and consistent on your messaging. Everyone should have a seat at the table. Everybody should be voting on this. Now I'm just saying, let's say that we had a representative democracy here, right, and we all elect you. And we want you because you know.
Can I say thank you? This was a wise choice. I promise I will lead wisely in your interest. This is all about you. It's not about me.
Amazing. I love that. So what rules do you put in place? And let's make them twofold. One, self. So are there limitations to what I can do myself? And then on the germline where this is now going to affect everybody. Yeah. What sort of, we don't have to get down to like subpoint, 14 on a big contractual thing, but just sort of broad strokes. Yeah. What limitations, if any, would you put on the self, and what limitations, if any, would you put on germline? Yeah.
So I definitely would have more latitude for people doing things to themselves, but not complete latitude. I mean, right now it's illegal to commit suicide. I mean, it's hard to enforce.
But do you think that's smart?
I think it's hard to enforce. I think we should stigmatize suicide.
But should we make it illegal?
Well, I'm going to pause and reflect. I don't think it should necessarily be illegal, because certainly I support euthanasia. But I also feel that we should make sure that it's discouraged, other than in some pretty terrible and extreme cases, because there are cultures that actually are much more accepting of suicide. Some Asian cultures, for example, and traditionally Japan. And I don't think that's healthy. So I think it's good to have bad things stigmatized. Whether making them illegal is the right way to do it, I don't know. And again, as I said, I support euthanasia in extreme cases, but again, in a regulated environment where it's because otherwise things can really get out of hand. But coming back to your question about, in terms of individual latitude, I think the individuals should have some latitude, but I also think that society has a responsibility to protect individuals' health. Like if I go to the drugstore
from themselves.
Well, like for example, that's why if I go to the drugstore and buy some kind of product or a drug, I want the government to regulate whether it's safe for me to take that thing into my body. If I go to a doctor and the doctor is doing some kind of procedure on me, I want the government to say, well, this is a safe procedure, or this procedure is within the bounds of normalcy. Because otherwise you go there and somebody would say, well, I cut off your arm, whatever the thing is. We need that. And I don't imagine that every individual has perfect knowledge. And so if everybody had perfect knowledge of all the risks and all the and all of the benefits of any kind of intervention, you'd say, well, geez, you go to the drugstore or you go to the doctor. Here's this range of stuff. You're getting your arms and legs cut off because you have a headache. It seems like a bad idea, but if you want to do it, go for it. I mean, we don't want to live in that kind of society. So I think there's.
All right, let me pin you down.
Yes.
So you've got in food anyway, it's called GRAS, generally recognized as safe.
Yeah.
So if an ingredient is generally recognized as safe, then you can put it in your food without having to seek any further approval or anything. But if you're putting something that's outside that list, then you may have to seek approval. Would you be in favor if there was a GRAS list of edits where it was like, we've tried these out, we went through whatever approval process we had to go through, we've gone through that. Is there anything that you would intrinsically say, this is only for self, I would not want them doing? You can't add a third arm, no third leg, no increasing your intelligence. Like, is there anything that, as long as it was safe, is there anything you would not want the self to do?
So I'll flip it a little bit. So let's start with the things that I would be comfortable with. So like the whole range of deadly single gene mutation disorders, once it's proven that these interventions could be happen and they're safe, and we're not there yet, again, which was why I'm so critical of He Jiankui, the Chinese scientist. But I think we will be. I think we will be relatively soon. I think it's that we're going to think about like a range of interventions, whether it's at the pre-implanted embryo stage, whether it's the embryo stage, newborn stage, whatever, and there'll be a certain time where it'll make most sense to intervene in most cases to prevent something bad. And that will, I'm certain of it, that will become a norm, and there will be a growing list of acceptable interventions that over time we know either are safe or that the risk is outweighed by what we know about the potential benefits. But as I write about in the book, that list is going to grow, and it's going to grow over time, and it's going to move beyond what we think about as therapeutic interventions into new areas that now we think of as enhancements. And I'm not necessarily inherently against anything, but I just think that it will make most sense for some kind of intervention to get on the "this is safe, we know what we're doing" list before people start doing experimentation or self-experimentation. And again, as I said, and the government has an interest in protecting us from those things. I mean, I listened to a lot of these different podcasts, and I was on Joe Rogan, and I love that podcast. But there's some stuff that people say, it's like, oh yeah, of course X is true, and I'm listening. It's like, well, wait a second, X isn't true. And when we're talking about systemic, life-changing interventions, we just need to be careful. Biology is really complicated stuff. We don't really understand human biology. I mean, if we think of all of human biology as like, if you understood it completely, that would be 100%. And if you knew nothing, it would be 0%. Maybe we're at 4%, maybe 5%. We don't know 50% of how our bodies work. So I think we need to be conservative, but I don't see any inherent barrier over time. I mean, if somebody is trying to genetically engineer their kids now for an enhanced intelligence, it's just not going to work. But
only because we don't know how to do it, right?
Correct.
Intelligence is just so complicated. It's the interplay of so many different genes that we haven't identified yet. Part of what I'm trying to walk through, and I find this so fucking interesting, is I want to get to, I want to remove some of what I'll call the more mundane, like you and I aren't actually making policy right now. You may be in the, outside of this podcast, but at least in the confines of, our time together, we're not actually making policy. So I'm trying to figure out like where the pain points are for you. So here's how I see it. So one, I watched somebody in the last couple days of their life, and they were fucking suffering at a level I was just like, this is so crazy. And he really was hell-bent to live up to this idea of like, I'll never give up. And I thought, wow, that's so impressive. And it was like, I was moved by it. And I have built my reputation on like, never say die, like keep going. And as I was watching him, I was like, this doesn't make sense. He should absolutely, my advice to you, dear friend that's going through this, is 100% euthanasia. Like this is a one-way street. There's no coming back from this. It is clear that you're within hours or days of passing away. You are so uncomfortable. Now, it should be his decision, 100%. But I know at one point he had looked at it and he was going to have to move states and all that. And so it was just like this real complicated mess. And I just thought euthanasia 100% should be legal. Now, like you, I consider it such a dangerous tool to employ quickly that it scares the shit out of me. But do I think that it should be illegal? No, I do not, because I just think it's so complicated. Now, when I extend that to my thinkings about one's ability to begin to modify yourself, I think you're a fucking idiot if you start playing with your genes, unless that shit has been tried by a lot of people before you. But my fascination, or my hope, is that enough people do want to be early adopters, that the government has gone through with definitely not letting this be the Wild West, but going in just like they do with food. And I think they make a lot of bad decisions in food, but it's better than no decisions being made, that they come up with a generally recognized as safe editing list, and that people then get to decide what they want to try. And that over time we'll get to see like, hey, what works? I will not be an early adopter, but I will certainly be paying attention for things like, if I could beef up my intelligence, I would do it 100%. If I could beef up my ability even to read faster, I would do it 100%. Now, of course, I'm going to, just like staying in good health, I would rather do it through diet and exercise than I would through taking a supplement. I like knowing that supplements are there so that if I'm unable to get to, whatever point I want, that I can lean on that, or even plastic surgery. I've not done it, but I reserve the right to. Yeah. So I'm glad that it's not illegal. So I definitely fall on the love regulation. I think that's so important to keep people, because they're not going to be educated, to make sure that they're not getting themselves in trouble. But I like the idea of like pushing the boundary of what we can recognize as being safe further and further out. On the flip side of that, now you've got germline editing. That one taps into something for me which is far more terrifying, which is, I think that we want to do it. I think we should want to do it, is a better way of saying it. But you want to talk about something that I think the discrepancy between what I want to be true and what will be true is so terrifyingly vast that if we could lock that, oh God, you really can't lock it forever. Yeah, And you
wouldn't want to lock it forever, just because, I mean, the whole point of evolution is buggy. When we mean random mutation, that means that every offspring of every species is different from their parents. And sometimes it's better and sometimes it's worse. And if we were just living totally in nature, then the better stuff, and better doesn't mean inherently better, it's just better suited for the particular environment in which it exists, that wins over time, and that's how species evolve. But for us, who kind of are wedded to being this thing, that means that every generation you have some good stuff and you have some bad stuff. And sometimes the bad stuff is so bad that it can kill you. And sometimes we call it cancers and other things. So I don't think that we should rule out any kind of intervention just because of the nature of that intervention. It's just that we need to be really careful and thoughtful about the cost-benefit analysis and the context in which we do something. And so I think it would be a terrible mistake to say never germline. I mean, I've had this debate with the Catholic Church, but that doesn't mean that the alternative to that is always germline or do whatever you want.
I want to drop this into the messy reality by quoting probably your publisher, but this was something written in the description of Genesis Code, one of your science fiction books. Yeah. It says, in 2023, America, bankrupt, violently divided by the culture wars, and beholden to arch-rival China, the rules of the game are complicated. And I thought, first of all, when did you write that?
Yeah.
What year?
I'm so proud of that. I wrote it, in I have to remember, like 2007 or 2008.
The fact that you put your finger on the culture war is crazy.
No, I have to say, I want to be audited. I want somebody to go through everything I've written, everything that I've said, and and tell me, which I kind of know, like how accurate it was. Because in this, I mean, in Genesis Code, I mean, that's what's happening. Our culture is divided. There are all these culture wars. We're ripping each other apart, and then there are all of these new technologies, which are amplifying these divisions and creating new opportunities for people to do things differently.
So when I think about like the tragedy of the commons and the fact that, hey, I'm looking at this whale in the water and I think it adds more value to my life to be in the water and to be free and, how beautiful that is. But then somebody else is like, fuck that. Like, I'm going to harpoon this thing and take it in and sell it for the oil. And you realize, well, man, then I'm here. Like, it is going to get whaled. So do I be the one to whale it? It's like we have seen that play out so many times, and it's so devastating, obviously not taking us anywhere spectacularly wonderful, and yet it is the reality that we face. And the fact that China has already done gene editing on living humans, you can see, like, we may not want it to be true, but the fact is that people are playing with this. And if we get, and look, it's not today, so everybody who's dismissing this by saying, why the fuck are they even talking about this, like, this is potentially decades out. It's going to happen. If you give us any, like, there's a great Elon Musk quote where he's saying about virtual reality, if you give any rate of improvement, you don't have to buy into Moore's law. It could take 10,000 years, but this is going to end up being a debate that has to happen. Same is true because the big question mark in gene editing is we don't know what genes actually do what when you take them in concert. But as you say in the book Hacking Darwin, we are not infinitely complex. We're just incredibly complex. And as long as there is a finite nature to the level of complexity, ultimately our ability to process that data with computers or whatever is going to reach the point where we will be able to say, this embryo equals this. This is your Einstein embryo. This is your Rain Man embryo. And like, you get a pick. And so, cool, I'm going to take my Einstein embryo. Okay, now, if we're playing that game, and I know that either very rapidly through gene editing or more slowly by just embryo selection, a nation state can take itself, like you can imagine when this is like the chicken that lays one egg a month becomes the chicken that lays an egg every day. What happens when it's Einstein, and then you take Einstein's Einstein baby, and then you take Einstein's Einstein baby, and like all of a sudden it's, you've got IQs of 300 or 500 or 1,000, and compared to somebody who refuses to play those games, I don't want to go up against somebody with an IQ of 1,000 with my, buck 15 or whatever that I'm hovering at. So it's like that gets gnarly. But what do you do when it's the culture wars tearing us apart? It's us v China or Russia or whoever. And like, they're going to fucking harpoon the whale if we don't. And now it's like, as much as I was about to say, lock that shit down, I'm like, oh man, you can't, because I don't want to become, I don't want to get taken over essentially by a nation that does choose to do that.
And so that you put your finger on exactly the point, and that I'm spending about 90% of my life's energy right now trying to solve exactly that problem, because if we don't solve this global tragedy of the commons problem, where we're just going to compete ourselves into out of existence, and that's, for me, I mean, this so I'm in earlier. I'll give you the quick backstory. Earlier in the year, in the very, very beginning stages of the pandemic, I was supposed to give a talk for Singularity University, which is like the university of the future, and I'm on faculty there, on whether the tools of the genetics revolution were a match for the pandemic. And that morning, I woke up and said, it's a really important question, but it's not the question. The question is what you just asked: is why is it that we weren't prepared for this pandemic, and why is it that we weren't able to prepare for any pandemic, and why is it that we can't solve any of these big global problems, whether it's protecting the ocean ecosystems like you mentioned, or climate change, or proliferation of weapons of mass destruction, or the big scientific issues, because we're all competing with each other. And the reason is this same global collective action problem, is that we are, our big problems are shared and global, but the way we're organized to address them, at least since 1648 and the Peace of Westphalia, which ended the 30 Years' War, is predominantly national. And so these kind of national forces that you've just described, they drove us into 2 world wars. And then we thought, oh shit, if we don't fix this problem, we're going to keep going war after war after war. And that was why we created this thin overlay of international organizations like the UN. But still, we live in this world of competing states. And the problem is that our little species of these African nomadic primates suddenly and very rapidly became a species with the ability, as we're talking about now, to fundamentally change all of life on Earth. So we're just this one little species. We now have this power, and we don't have an infrastructure that allows us to come together to solve these kinds of problems. And so that's, that talk went viral. Then I stayed up all night. I drafted a declaration of global interdependence. That went viral. I called a meeting of people on my email list. I had 130 people from 25 countries. And together we launched this, what's become one organization, One Shared World, and OneShared.world. Now we're a community of people in 110 countries. But the goal is to solve this global collective action problem. Because if it's everyone for themselves and every country for themselves, our species is now so powerful, we're going to wipe ourselves out.
So what is the sort of key tenet? How do we pull that off?
So what we have to do is first we need to recognize and articulate our interdependence. I mean, that's the problem. I mentioned I'm an advisor to WHO. This pandemic could have been stopped in its tracks if we had just built the World Health Organization that we need, a WHO that had its own global surveillance system, that could send investigators anywhere in the world on a moment's notice, unlike in the actual situation where China blocked them for almost a month, where the WHO could coordinate a smart, collective response to the pandemic. If we had all those things, we wouldn't be in this predicament that we're in now. So what does it look like? It looks like every organization in the world, every business, every civil society group, every government, every political party has to recognize that we have our core constituencies, the people who we represent, whether it's the citizens of our country, and we have our collective constituency of our species and our planet. And that we have to ultimately, coming back to your thing of killing the whale or not, it's the same point as whether you do germline edits or not. We have to do a cost-benefit analysis. But if everybody is thinking just cost-benefit to me, then we're gonna kill ourselves. And so we have to not just change consciousness, but then use that changed consciousness to change the institutions around us.
But do you have any sense of how we actually pull that off? Like, a lot of, when I hear stuff like that, I'm like, yes, but humans aren't currently wired that way. And so I think about this a lot in the context of AI, and people are always worried that, the paperclip problem, that if you give AI the incentive to make paperclips, it'll look at you and be like, those atoms would be way better used as paperclips. So it doesn't kill you to kill you. It kills you to turn you into the superior paperclip. Right. And so, but that desire was programmed, right? And minus that desire, it's essentially inert. So I started thinking about desires as sort of being programmed, and I think about humans as sort of wet AI. And through evolution, we've got these imperatives. Now, maybe somebody's taken the time to write them down. It'd be super interesting to see somebody's take on what our imperatives are. Yeah. But we're driven, certainly at a really simplistic level, towards pleasure, away from pain. And nature has made things like sex very pleasurable so that you have kids that have kids. And things like getting injured very painful so that you stay alive long enough so that you can have kids that have kids. So that is, at a really basic level, it shows if you want to change the outcome, you have to change the incentive structure. And so if evolution has given us a set of imperatives, like how do you get a radical change like that without a dramatic change in imperative?
Yeah.
And then maybe that begs nature versus nurture, but
I don't think
like how do we
I
solve
don't think
that?
you have to go that far because there's no national imperative in evolution. I mean, you're in California, I'm in New York.
Isn't
No,
there?
I mean,
Like we're so tribal.
we're in trouble, but those tribes used to be, some small group of families that were together, and then it was like, oh, those assholes, over there, that other tribe. But then we've grown, and so then it became, people in your region that was the us, and the other thing was the them. And then now it's the people. I mean, you've all know Harari talks about this in your country. I mean, I haven't met most people in the United States. I feel like, well, when we feel that way, we're kind of on the same team. And sometimes we'll have like a World War II where everyone will really feel it, and then we'll have a time like now where people don't feel it quite as much. But there's nothing natural, there's nothing inherent about a national identity.
Let's dive into that because I'm going to have a hard time moving past that one.
Yeah.
So I agree that it isn't inherently national in nature at all, but the national is leveraging something that already exists, which is us and other. So if we know
that, you could change it. You look at, like, for example, these young kids in the global climate change movement. I mean, they've kind of decided, well, I'm less an American and I'm more someone who wants to change the climate. I think that
but they're just changing the us and the other. So what I'm saying is you have an us and other problem. And so there's a reason that so many great science fiction. Have you read the comic book, the graphic novel, The Watchmen?
Yeah, it's so funny.
It's different than the movie.
So I have to say, I haven't read the comic book. I saw the series, which I loved, even though it totally collapsed in the end. But before that, I thought it was great. And then I went back and watched the movie, which I thought sucked. But the idea that you kind of create the giant squid to kind of, because I do think that we have this us and them, but the categories of who is us and who is them are really malleable. And so if the us is us, our little tribe, or us, our country, or whatever, the them can be the other tribe or the other country. But it could just as well be, with our exact biology, that the us is humanity and the other are these forces that are trying to, that have the potential to destroy us and destroy our home.
That's so abstract. I don't think humans are going to get down with that. Like when I really, really stop to think about, okay, how do you, so impact theory, its whole thing is like, how much can I actually influence the cultural subconscious? So I think a lot about like how you get people to group up. And it does seem true to me that you need a very compelling, tangible other to bond people together, just like at a neurochemical level, right? That you would be expressing vasopressin, oxytocin, that you're bonding with these people in a very non-abstract way, like a super concrete way.
But how about if you just replace this giant squid with a virus that is attacking us and killing all of these people?
We just ran that experiment. Did it work?
But it didn't work, and we're dying because it didn't work. And I think that's the big.
But that's what I'm saying. Like, I wish it had worked. Like, that would have been rad. And honestly, for a brief second, it looked like it was going to work.
But it's still playing out, and we don't know whether it will or won't work. I mean, the way I always say this year, it's kind of like a 1918 year where there's like some good possible futures we can imagine, and there's some bad possible futures that we can imagine, and the good ones are better. But yeah, you're right. I mean, 1945, we were able to do all these kind of new things because there was this devastating war. 75 million people died, and the good guys won, and we're able to say, hey, we're going to do things a little bit differently. And so it may be that this crisis isn't big enough, but if there was ever a learning opportunity to say, well, how do we handle this? And I think this is the way we have to come together, because let's say that we get a control of this virus. Who's to say there's not 2 years from now, 3 years from now, 5 years from now, a synthetic biology, a genetically engineered virus that's 100 times worse? And so I'm not saying that we definitely will succeed, but I think that it's not pushing against our evolution in any kind of way that's different from the idea that a bunch of different people can all have that same identity as being part of one country. I mean, it may be that we are an us versus them species, but there's a lot of different ways that those forces and impulses can be configured.
Okay, so as my elected representative to make all these decisions, I have a pitch that I want to make.
Yeah.
And tell me if you think this is crazy. So when I think about, okay, the way forward, it's messy. You've got countries for right now. Maybe we can one day transcend that. That would be amazing. I love the idea of when you draw a circle to exclude me, I'll draw a bigger circle to include you. I think that's spiritually so rad. But right now we're in like a super messy place where it's nations fighting against each other, resources being limited, and so you get all the madness that we're all experiencing right now. Within that confine, one thing maybe that we could get people to get on board with would be, we're going to totally say gene editing, except for Mendelian. What is it?
Mendelian. You got
the single Mendelian.
Yeah.
The single like mutation genes, those that are like just horrendous diseases that are very easy to edit. Yes to that. And unfortunately for now, we have to say no to everything else. So even though you could spare some human suffering, there's just too many unknowns, so we're not going to play with that. So yes to Mendelian, no to everything else. But what we are going to get behind is a 10% improvement across, let's say, 10 variables: longevity, intelligence, whatever. You're going to end up telling us what the 10 are. But across 10 things that we agree globally, and those are examples of what I mean, we're going to push for a 10% improvement, just mathematically. And we're going to do it through embryo selection. So that would require us obviously to beef up our ability to assess what genes equal what outcomes. But then, because technology, the best definition of technology I've ever seen is technology is a hope for a better future. So you have to give people this belief that life is going to get better for their kids and better for their kids and better for their kids, because that ultimately, I think, is what people are really fighting for. To be like, yo, I made all these sacrifices so that my kids would have it better than I had it. I love that impulse. I think it's beautiful, even though I don't have children. So that to me makes sense. And if we capped it to something manageable so that no one generation felt like, I'm being totally left behind, that it's 10% improvement, but over 10 generations, like, you've got a doubling.
Yeah.
What do you think about that, Representative?
I love you, Tom. Bad idea. So here's one. So first, it's not, we shouldn't feel that the single gene mutation, the Mendelian interventions are good and others are bad, because some of those interventions may end up being good, some may end up being bad. It really depends. And also for these more complex interventions, we don't know what's going to work. What we need is not rules, because any rule that we set is not going to make sense when the messiness, when it faces the messiness of the world. But what we can have are values, and values of what we believe in, and a level of certainty, of confidence that something is going to work to drive a desired outcome. Because it's not just that our bodies are really complex. And so let's say we said we're going to make ourselves 10% smarter. We have no idea what comes with that 10%. It could be madness. It could be all sorts of things. And so I think that for me, rather than
But if we were making 10% improvement, we would have the chance to pump the brakes if we see a problem coming.
The thing is, but I think we should always be exploring everything, using this kind of cost-benefit analysis, integrating our best values, and having a broad, open, public conversation and process, so we can make those decisions. Because it may be that 10% is too low. Maybe we need to be 500 times smarter than we are in order to survive, because we know our planet is going away. I mean, I think there's this is again my piece for the Vatican was about this, in which why I was so surprised they actually published it, because I said exactly the point I'm making to you, is if we try to live by hard and fast rules, those rules are going to be immediately obsolete. what we have to do is say, what are the principles that we want to guide us, and what are the structures that we'd like to build to help make these balances in an inclusive democratic way, and then explore carefully and cautiously what's working and what's not working. And there may be some areas where we think like, that's incredible. My feeling is if we can extend healthy lifespan, I'd say no limits. I mean, I'd love to have, my parents living, to their hundreds and 120s and 200s and whatever. So I don't think we need to impose imaginary restrictions on ourselves for futures that we don't know yet. We just need to keep moving forward and keep moving forward carefully.
Okay, so now to push this a little bit farther. One thing I've learned in business, this is an immutable truth. You are only as good as what you write down.
Mm-hmm.
So you, at some point, the values, the system has to be translated into a document.
Yeah.
When I think about the U.S., the Constitution's been pretty amazing, right? You put this document down, your ideals, maybe
Right.
you could even call that your value system. You put in sort of a formal structure to things, so there's checks and balances. I think it's really quite brilliant. Do you have sort of rough swag notions that would be put down? If we were going to go back and write the Constitution again, I think we would change men to people, right? So all people are created equal. Like, that's a pretty rad start. Do you have something like that in terms of how we need to think about it? Like, specifically, what is the value set?
Yeah, so two questions. In terms of writing it down, there have been efforts to do it. UNESCO did it. The Council of Europe did it. It's never perfect. It's so far actually hasn't even been that great. But I do think that the value set for me are, one, we need to have an open environment for science. Two, we need to have...
Meaning that all information needs to be put out there?
Well, I think it's just that we shouldn't be trying to cut down the basic science to prevent some kind of theoretical outcome in the future. I believe in science. I believe in scientific experimentation. And I know that people who are going to be asking these questions about what are the rules, some subset of them are going to be people who say, well, let's just shut down the science so we never have to ask these questions. So my point number one is I really believe in the science. I believe in the process of scientific exploration, and I think that needs to be really important. Number two is that in terms of the process, this has to be an open, inclusive, transparent process that we can't have even very smart people, even specialists, making decisions about the future of life that apply to everybody. This is up to everybody. And
So should it be voted on?
Well, so that's a big question. It's connected to the work that I'm doing with One Shared World and with the World Health Organization. So governance systems it's not just one thing. I mean, right now when we think of how is genetic engineering, for example, regulated, it's not just laws. It's internal review boards in hospitals. It's how scientific publications operate. And there's a lot of different pieces of this. So yes, there are laws and they need to be written down. But in my mind, we should think also in terms of processes, because it's not going to be any one thing, any one mechanism that fully establishes a governance. And then third is that we need to have regulatory infrastructures that, in my mind, the best regulated, at least for genetic engineering and human fertilization, and is the United Kingdom, where they have a really thoughtful process where they're actually weighing costs and benefits of different interventions. So I think that every country needs to have a system. Right now, some do, and some don't have anything that balances these kinds of international best practices.
Is this like the FDA of genetic alterations?
It is, but it's the UK system is just much more thoughtful. I mean, FDA is a great agency, but it's much more thoughtful, and they've, like, for example, there's a procedure called mitochondrial transfer. Just a quick summary is the mitochondria are the power packs of your DNA, the power packs of your cells, I'm sorry. And if you think of your cell as like an egg, The nucleus is the egg yolk, and the cytoplasm is the egg white, and the mitochondria exist in the egg white. When some women have faulty mitochondria, they pass them in varying degrees to their children, and that can cause all kinds of things, including early death. So there's a process called mitochondrial transfer, basically swapping egg yolks from one with the diseased mitochondria to one with a healthy one. It's banned in the United States. In the UK, they had a 3-year national debate. Then they had an open vote of both houses of parliament, and then they passed it to this Human Fertilization and Embryology Authority to regulate. And so everyone who wants to do it, you have to apply first for your clinic or your lab, and then for each application, you have to apply again for each specific application. And they have all these experts and very thoughtful people who are making those decisions. I mean, it's a really smart way to do things. We don't have that, and certainly we need that. And then finally, and that will allow us to do this kind of cost-benefit analysis, which I think is essential. And then the final piece of it is that I think it's okay for society to define red lines beyond which we don't think people should go, even though those may change over time. So we had, after the Second World War, the Nuremberg trials, where to say, well, there were things like human experimentation, which we think are so wrong that we're going to create an international standard saying that they're wrong. And so, again, we have our access to read, write, and hack the code of life, and there are all kinds of really nefarious things that people could do, including human experimentation, including, let's just say, I mean, this is a kind of a caricaturish example, but there was some country like North Korea that said, all right, we can do embryo selection, some minimal genetic engineering to divide people into certain classes. We want a certain class that's more docile, more subservient, or whatever. And let's just say hypothetically, I don't think that we would say, oh, just live and let live. That's North Korea. That's just North Korea being North Korea. I think we'd say we want to have some standards about what is and isn't okay, and that we collectively, like we do with all sorts of issues in international law, come together to start to try to articulate what those things are.
All right, you just scared the shit out of me. So you've got your science fiction ability to predict so much that you want the audit to see what you've been right about. Walk us through what I never contemplated a future where a society would want to do that, but as soon as you say it, it seems almost self-evident, naive to think that they wouldn't. What is going to happen? Like where are we headed over the next, and I don't know what timeline you think is most relevant. So you've got sort of near term in the next, call it 20-ish years, but then what are we talking about in the next like 100 to 200 years? Where do we go?
So when you go, and I write about this in the book, if you go to the Olympics, as I've done, you see different forms of societal organization competing with each other. Like when I went to the Beijing Olympics, I went to the volleyball. I think it was the bronze medal game. It was the U.S. versus China. And when I saw the Chinese team, it was just clear that everybody had been selected based on some criteria when they were a little kid. Like all I don't know all the things, but all the setters were like the same body build. All the spikers were the same body build. They clearly kind of searched around, and and for the Americans, we had all these different people of different shapes and sizes, and someone had like extra spirit, and somebody tried really hard, and then we competed, and somebody won because it was two forms of societal organization competing with each other. That's what's going to happen, even if we are as collectivist as I've articulated. That's what's going to happen with us. And so, just like there was Athens and Sparta in ancient Greece, let's just imagine that you're Sparta. Actually, we can make it Athens, because this is based in part on Plato's Republic, where everybody had a role. But you could imagine a society that had identified that believes that outliers, which is probably true for lots of societies, that outliers are the ones who push the envelope of possibility. And so for our physicists and our abstract mathematicians, we want them to be like superstars. And our athletes, we want them to be superstars. And rather than leave everything to chance, we're going to screen every embryo of people who have the potential to be born. Once we make the selection of which embryos are implanted, we're going to have a pool of people who have the genetic possibility of being the Einsteins or the Usain Bolts or whatever the thing is. You could also add a genome editing, a genetic engineering component where you maybe make a couple of changes to those embryos to maybe give them some kind of boost or prevent some kind of
what are the
harm.
boosts though that you think people are going to go for? So if I forget the exact quote, but it's something like the science fiction writer's job is not to imagine the car, but to imagine the traffic jam.
Mm-hmm.
What thing is it going to be? Intelligence? Is it going to be
Well,
athletic prowess?
I
Like,
think it'll depend, but there's all kinds of things that people want. There's the general things that people want to live longer, healthier, more immune to disease. People tend to want to be smarter as long as it doesn't come with a high cost. And my guess is people will probably find that it does. And so I think it won't be kind of rocket science, but then there'll be outliers. And then there'll be individuals and societies who say, well, my life is based on being X. And you're going to have to make those, if you're talking about genetic engineering, you're going to have to make those decisions. Those decisions will have to be made for you before they're born. And people always point to the movie Gattaca about, well, isn't that so terrible that everyone's been identified for their roles? And certainly that's the theme of the movie. But when I saw that movie, I had a different outcome. It's like, God, this guy, Ethan Hawke, he's not genetically enhanced. He's snuck his way into the space program with all these people who are genetically enhanced. If I'm in a space program, I don't want some non-enhanced person being a liability because their bone structure isn't able to resist the radiation in space. I mean, I just think that we may become super specialized, and we may want, or for our survival, we may even need people to play a certain role. I mean, how much of our lives now are dependent on innovations by people like Alan Turing or John von Neumann or other of these kind of giants who opened up possibilities that we now occupy? Like, maybe society would be better off if we had more of those guys. I mean, or maybe it would be better off if we had less of those guys. And I don't think we know, but we do know is that these different systems are going to be competing with each other. And as happens with evolution, we're going to be constantly throwing up variation. And some of that variation is going to prove good within the context of a particular environment, and some isn't. And over time, we're going to know.
do you think we will slide towards uniformity, or will we slide towards massive diversity?
It's a great question. On one hand, you can understand uniformity, because if you ask the average person, what do you want? People tend to want the same things, which is why when people go to sperm banks and they have a choice of what they want, a lot of people are picking, well, I want tall, I want this, I want that, even though there's nothing inherently better about being tall than being short. It's rewarded in our society. In Ewok Village, they hated the tall people. And so on the other hand, so you could imagine all these social pressures that because no one's going to want to, well, I'll invest in diversity by having a kid who's got a greater likelihood of dying of some terrible genetic disorder. People say, well, geez, I don't want that. Let somebody else be the carrier of diversity, even though that gene that may increase the risk of some terrible disease may also have some benefit that we don't even know about. On the other hand, you could imagine, we're a social species, so if I had to bet, I would bet on uniformity. But you could imagine that people say, well, geez, I'd like to be blue. I'd like to have whatever the thing is. You could imagine people wanting to do it, and if it was meaningful enough, maybe it could have some kind of evolutionary impact.
Yeah, I think that there will be values will come into play again. And what you're going to see is the people who value, people's temperament tends to break into certain sort of archetypes. Yeah. And I think each archetype is going to optimize for the thing that they value, whether that's creativity, whether that's intelligence. You will certainly see parents, if we're talking about germline stuff, you see parents trying to optimize for their kids not struggling. So I want my kid to have it better than I did. Right. So if you were artistic, but maybe you flirted with like bipolar disease, then your parent wouldn't want you to struggle in that same way. So it'll be interesting to see how that will fluctuate. And I think while we'll probably oscillate towards uniformity and then back out, because what will happen is if everybody optimizes for intelligence, then you run into, no matter how intelligent you are, you're all you're just now competing against each other, right? So then how do you stand out? You stand out by being more creative, or, so it'll be really interesting. I think even if people try to game the system, they'll inherently run up against the weaknesses of uniformity, or they'll run up against, well, I wanted them to, be different and for there to be diversity, but there's a huge price to pay. And now my kids are struggling in a way. And so those kids end up rebelling, and they have the most conforming children because they didn't want them to struggle the way they did. So it feels to me like you're going to see, that sort of oscillating pattern.
Yeah, you
can't be super easy to see.
Yeah, but the other thing is that there could easily be funnels. I mean, one of the reasons why humans, we're more similar to each other, to all humans, than say chimpanzees are to other chimpanzees, is that our ancestors have gone through these very narrow funnels where almost all Homo sapiens died because of starvation or climate change or whatever, and a tiny number of them survived. And so the genetics of those tiny number who survived became all of our genetics. So what you're imagining, which I think makes sense, is humans living on Earth, or living on Earth in this environment. But you could just as easily imagine that there's some group of us, which I think will certainly happen, that leaves this planet and goes and colonizes someplace else. And so that's kind of the beginning of that funnel. And who those people are, let's say it's all the people who've given themselves blue skin. There'll be an entire species of, blue Homo sapiens, and that's just going to be their reality. And just like us, when we see those evolutionary charts and we have, Ramapithecus and Homo erectus and Homo habilis, it's like, oh yeah, those creatures, which is how we see them, that used to be us, but now we're this. Now we're Homo sapiens. And I think these guys, these Homo bluians, will say, oh yeah, see those pale people on the chart, that used to be us. And we passed through this funnel, just like our ancestors passed through the funnel. And now this is us in this new reality. And whatever those attributes, that will be them.
One thing that I think that most everyone will strive towards will be immortality. Agree with that? Disagree with that? And do you think that there are any inherent problems with striving for truly living forever?
So I'm all for it. I mean, if I could do it, I certainly would. There's nothing wrong with it. A lot of people say, well, what about overpopulation and whatever? I think it's totally fine. I just don't think it's achievable with the physical bodies that we have. And even if you start living a really long time, just the law of averages, gets you. It's like, I didn't know penguins could get rabies or whatever. It's like that outlier will eventually get you. So I don't think it's achievable. I think that striving for it is a good idea. I mean, I'm pretty deeply involved in the science of human life extension, and a lot of people think, oh, it's like Elon Musk or sorry to use foul language on your show, but that dickhead Adam Newman.
Who's Adam Newman? Why is he that dickhead?
The founder of WeWork.
Did he do something dodgy?
He had a whole thing of wanting to control the science of human life extension, and then use it to go to people with like billion-dollar companies and says, I want to buy your company, and I'm going to pay you $1, but I'm going to give you the secret of human life extension in exchange for your company. Actually, I heard him say this.
What?
Yeah, it was insane. It was insane. And um, so there's a lot of crazy people, but there's a real science of human life extension, which is really great because these terrible diseases, cancer, heart disease, dementia, that we fear are all correlated with aging. And so if we can slow the process of biological aging, we can do more to fight cancer and these other terrible diseases, I think, even than we can by investing directly into mitigating those diseases. Because if you eliminate all of cancer, we only live about 3 years longer. But if you can slow the process of aging, we can live hopefully much longer. But it's a new field of science. But I think it's great for us to strive for immortality. And I also think some people say, and I disagree with this, that it's the finitude of life that gives it meaning. I mean, everything is the meaning of life gives it meaning. I mean, there are all kinds of people who are finding meaning in all sorts of things, and death could be it for somebody, but it doesn't have to be so for everybody.
What do you think? So if nature had a conceivable answer, which was like there's a jellyfish that is immortal. Mm-hmm. So we know there's nothing sort of biologically necessary. Humans could have lived or maybe you said that you actually think that we couldn't in our current form. So what is it in our current biology that makes us different than the jellyfish? Why couldn't we live forever?
Yeah. So I'm glad you mentioned the jellyfish. In my most recent novel, Eternal Sonata, that's the immortal jellyfish is actually part of the theme and the science to crack the code of immortality. So the reason why I think it's going to be hard for humans to live forever, I mean, that immortal jellyfish, it goes from kind of adult back into a polyp and adult and polyp. So by that standard, we kind of do live forever in the sense that, an adult male and an adult female, they give their cells to each other and then it reconstitutes as a newborn baby who's not 50 or 60, but zero. But why we in this physical form, in my view, is just we can extend healthy life. I think that will definitely be possible, and we're already doing it. But there's too many damn parts. I mean, I just think that this is when I talked about theology before. Like, I love the intelligent design people who would say, like, oh my God, the body is so complicated. There's so many moving parts, and if one thing goes wrong, then you would die. Only God could come up with that system. And I just think, well, I don't call that intelligent. That's shit design. Here's an intelligent design. You have two parts. There's the body and there's the head. The head screws off. When the body gets old, you just screw off the head and screw it back on another body. Like that makes sense to me. I just think that right now there's so many different systems it's like you have a car, like cars don't last forever. Even well-maintained cars, because there's always something. Would it be possible, conceivably, to replace each part one at a time? And that's what's happening now with these synthetic genomes of very single-cell organisms, where they're replacing one little piece, one little segment of DNA at a time, and they just kind of keep doing it until eventually they've replaced the workings of this single cell organism with basically the exact same code that it had before, and maybe some small differences, but just in this format. And so the question is, could we shift to another format? And to do that, we'd have to find a way of downloading our consciousness, and that's where we're very, very far away. We know nothing, next to nothing, about how the brain works. But even if we were to do that, which would be, I don't think we're 100 years away. We may not even be 1,000 years away from that. But let's just say we did it, then it would be more you than you just being dead. But let's say your consciousness gets transferred into some kind of other receptacle, whether it's a computer or a robot or whatever. Like, I think that would be you, maybe at that moment of transfer. But then that robot's out kind of doing its own thing and whatever. And it's just like, it's not that our our brain and our consciousness are totally disassociated from the complexity of our biology. So, any long answer, I think we need to explore all those issues. I'm all in. I say we extend life as much as we can in a healthy way and strive for immortality. And that, for me, writing books, being on podcasts, which I hope you're preserving this for thousands of years. Like, I think it's all part of that very human aspiration.
Yeah, it's interesting because I don't have kids. The sense of living forever is, I guess it could come down to like creating a work of art that I think is going to live beyond me, but just the percentage of things that live more than a couple generations is essentially zero. Yeah. And so I don't take a lot of refuge in that. And when I think about, there almost certainly are limits to the human body. Well, there are limits to the human body, obviously now, and they may be truly unovercomable, like you're saying. It makes me wonder about, okay, uploading myself into the cloud, would that experience even be recognizable? If I could forget for a second that it would have to be simultaneously the me that exists now dies, and the me that comes online has a sense of continuity. Otherwise, you're still going through the same problem that you were trying to avoid, which is I don't want to die. Yeah. So when I think about how the biology really does make us who we are, and something I talk a lot about is you're having a biological experience. And by that, I mean your brain as an organ reacts in a certain way using neurochemistry to make you feel a certain way. Your hardwiring makes you act a certain way. So if and you talk about this in Hacking Darwin, we're probably roughly 50% hardwired and then 50% malleable. So if I know that 50% of who I think of as me and this experience that I'm trying to preserve is hardwired, and that it's this incredibly complicated interplay between the mushy brain and the microbiome and the way that, my vagus nerve is taking, it's like 80% of the vagus nerve is sending body stimulation and communication to the brain. It's not even 50-50. So if it's like my body is making up this huge part of who I am, and there's all this sort of real-time feedback between the brain and the body, and that 80% goes away as I'm uploaded to the cloud. Now, of course, you could sort of mimic it, but then you start asking questions. Well, do I really want to be limited to the way that I am now? Or do I, going back into that, like, but don't I really want to optimize a little bit? Don't I want to be smarter? And so then it becomes this question of, what am I really preserving? And look, if I could live forever, I would. Like, that is something I would do in a heartbeat, 100%. Like, I am far more interested in the upside than the downside, but it is like this really sort of tangled up question. And one of the things that I've come to recently, because I used to be really hardcore about, I want to live forever, that's it. And then just asking the question of, why don't we live forever? And a quote that I'm haunted by is that science progresses funeral by funeral, or one funeral at a time, whatever the exact quote is. And it just got me thinking about the way that humans tend to, like, their belief system begins to calcify and they get stuck in their own way of thinking and they're not able to challenge themselves. And so I didn't know about the jellyfish, that it sort of reverts to a polyp and then back out. That makes a lot of sense. Like, in some ways you have to break out of who you are, the way you think, in order to renew. And that sense of renewal, I thought, is probably one of the things that nature has blindly, but still optimized for.
Yeah, maybe. I mean, and certainly I think that let's just say that all of a sudden you or I or somebody else was granted, I don't know by whom, immortal life. Then you say, all right, well, I knew this stuff. I did it for 100 years, and now I'm gonna reset. And it doesn't mean you kind of reset by wiping out your brain, but I just think that we'd kind of figure out some kind of cultural way to keep growing. But I think that the basic issue is that we're, like I said in the beginning, we are just animals, and we have these biological evolutionary imperatives of just to kind of keep going without any kind of rhyme or reason. It's just kind of built in. And so it's good news and the bad news. I mean, the good news is that nature wants us to procreate and creates all these pleasures and other things that push us to procreate. But then after we're done, it's not like that nature had any real incentive to kind of keep us around past reproductive age. It wasn't against it, it wasn't for it. The good news is because it wasn't heavily selected against, it creates more malleability. I mean, if there's like we're heavily selected for needing to breathe oxygen. If we said, all right, we're going to try to change that in humans, it's basically another species, and I don't think we could do it. But nature's kind of hasn't really, in any meaningful way, given a shit about whether we live to 40 or 80 or 100 or whatever. And so at least it creates malleability. When we look at different examples of the animal world, there's some of these long-lived animals, Greenland sharks and some turtles and other things, naked mole rats. And we can just say, well, what are some of the lessons? And a lot of it is slowing metabolism, which we can do. Some people can do it with lifestyle, but then there are different drugs that people are experimenting with called like metformin and rapamycin and nicotinamide and others that are trying to kind of trick our bodies into going into that low metabolism kind of screensaver mode.
Yeah, that stuff is interesting. Whether that'll bear fruit or not is another question. And you want to talk about making me nervous in terms of taking an exogenous substance that's slowing down my metabolism. It's like, what are the things that we don't know about the consequences of that? I'm
totally with you on that, because people, like, I write about this stuff and I know lots of the researchers, and people say like, well, what are you taking? And I say, well, I'm not taking anything. These are I'm taking exercise and fruits and vegetables. Because these are like systemic drugs. I'm not against taking systemic drugs, but like you said before, I don't want to be the first guy saying like, like I heard on Joe Rogan that NMN helps you live longer. I'm going to take that. But I think that I want to be the 10,000th person or the 50,000th person to take an intervention, and then by all means let's do it, because it's not like just fruits and vegetables and exercise are going to get you that much more. But I'm all for the scientific method and figuring out what are the hacks and doing them safely.
Yeah. Speaking of hacks, the book Darwin, Hacking Darwin, starts with you freezing your sperm.
Yes.
What is your advice to people on that? And why did you do it?
So first, with the advice, everybody, I mean, unless you already have kids and don't want any more, if you are going to have kids at some point, definitely freeze your sperm and probably freeze your eggs. Because
why the difference?
Well, just because sperm, average guy, I mean, it's like a little bit of money. You go there, they basically stick you in a broom closet, they give you some dirty magazines, they give you a little plastic receptacle. It's like, so the only, it's like the plus minus. Like plus, it's like, well, that wasn't that bad. Minus, it's like some money. It's not a huge amount of money. For a woman, as at least in the current system, you have to take pills or shots. You have to have a semi-invasive surgical procedure with some level of anesthetic. I mean, it's a bigger deal than it is for a guy. But the reason why I did it and why I think everybody should do it is I think that we're moving towards this form of procreation anyway. We're going to be a sexually reproducing species, but just less so through the act of sex. And if we're going to do it anyway, why not freeze your eggs or sperm when you are young and healthy as possible? And even if you do it and it's wrong and you don't need it, well, then just throw it away. I mean, so it seems like the upside is potentially huge, and the downside is relatively small. It's a bigger downside for women than for men. So I tell everybody to do it.
And in the book, you talk about doing it as young as you can. Why does that matter?
Just so that at a certain age, it's not necessarily always as absolute young as you can, but there are kind of peak ages for men and for women. I don't remember it exactly, but my guess is men is around 20 and women is around 25. And it's just that our bodies start to take on mutations with age through exposures. And some of those mutations are passed on to offspring through our eggs and our sperm. So it's just, if you're going to freeze, you may as well do it when you're at your reproductive peak.
That makes sense. Jamie, I think that is the perfect place to tap out, as people now, they have a mission. They need to run out and get this stuff frozen.
Yeah.
Dude, thank you so much, man. I just could not have been more into your book. I'm super excited to see what else you do, both on the fiction and the nonfiction side. So, my man, thank you. And where can people find you? Where can they pick up the book?
Yeah, that's great. So they can find me at my website, jamiemetzl.com. You can also go to the hackingdarwin.com site to learn more about the book, and you can pick up the book there. And given that most of us are living virtual life, you can go to your local bookstore, wear a mask. And then if you want to learn more about One Shared World, you can go to oneshared.world.
Awesome. All right, guys, if you haven't already, be sure to subscribe. And until next time, my friends, be legendary. Take care.
It makes me want to live life to the full and to encourage other people to do the same. The only life we've got. So let's live it to the full, and let's leave the world a better place than we found it.